Hello everybody, how's it going? Welcome back to my channel or welcome to my channel. This is Prodigious Mind, and in this video we are going to discuss about Linux file permissions. We are also going to understand this concept using different examples and how we can set different file permissions on a file or a directory. Before starting this video, I request you to subscribe to this channel and hit the bell icon for turning the notification on, so whenever in future I upload a new video, you will be notified at earliest. Alright, let's just get started. In Linux and Unix-like operating system, both a directory or a file is known as file. In simple words, for the operating system, there is no difference between a file and a directory. A directory is just a file which contains name of different files. Linux file permission is a security feature which allows the creator of a file to manage restrictions such as read, write, and execute over a file. It is an access control attribute which is given to a file and is stored inside the metadata of the file. It allows an owner of a file implement different kinds of restrictions for different users over it. In Linux operating system, a file has three different users. The first one is the owner user, or simply called as user, which is the owner or the creator of a file or a directory by default. The second one is the group user, or simply called as group, which is the group the creator of a file or a directory is a member of. The third type of user is the one who is neither the creator or owner of a file nor a member of the group the owner of the file is a member of. These three types of users can be changed using commands such as shown or showgroup later after the creation, but by default differentiation of these users are the same as we just discussed. Let's understand all of these users with an example. So now let's create a file first. As you can see here, we have user 1 as the owner or the creator of this file and also as the group user. Earlier we discussed that the owner or the creator of a file is the user by default. In simple words, when a user creates a file, the owner user is the creator of the file, and all the users that are member of the group the owner is a member of comes under the group user. You must be wondering that we can find the owner user and the group of the file here, but what about the third type of user, which is other user of this file? So any user that is not the owner, neither a member of the groups, comes under the other user. As you can see, we have three split terminals on the screen. In the first terminal, the owner user is logged in second terminal, a group user is logged in, and in the third terminal, we have other user. If we do ls-la, it shows a list of different attributes of files in the directory, such as permissions, different types of user have, owner users and group users name, modification time, name of files, etc. Let's just break down the permission section bit by bit. There are three basic types of permission or restrictions attribute a file can have, which are read, write, and execute. As we now know that a file has three different types of users. That's why we have three sections which shows permission of file or directory for these three different users. Each section can also be broken down further, which contains file permission attribute which are read, write, and execute. The first three characters or the first section is for the owner user, the second three characters or the second section is for the group user, and the last three character or the third section is for the other user. Read permission is represented as a small r, which shows whether a user can read the content of the file or not. Write permission is represented as a small w, which means whether a user can write in the file such as delete, modify the content of the file, or edit it or not. Execute permission is represented as a small x, which shows whether a file is executable or not. This permission is given to files such as executable file and scripts written in a programming language. This is needed if a user wants to execute a file without mentioning the path of the interpreter while executing it. A script written in a programming language is called as an executable file if it has execute permission set. Presence of these attributes shows the availability of the actions. For example, if in a section write attribute is given, it means the user can modify the file or delete it. Same way, if any of the attribute is missing, which is shown by a dash, means that the user don't have permission for that action. As we can see here, there are some places which have dash, which denotes the absence of the permission attributes. This small d here means that the file is a directory. Presence of a small d character shows that the file is a directory. I hope we have no problem in understanding things we have discussed so far. Even if you have difficulty understanding it, don't worry and let's proceed with our example. The owner user have read and write permission for this file. The group user have only read permission. As you can see, we cannot modify or delete this file. The other user don't have any permission as it can neither read or write to the file. Now the question is how we can set these permissions on a file. We can easily set these permissions using chmod command. Chmod command has two modes known as absolute mode and symbolic mode. In absolute mode, permission attributes are given using a 3-digit octal number or a pair of 3 octal numbers. Each digit can have 0 to 7 range. A single digit contains all 3 types of permissions which are given as for read we have 4, for write we have 2, and for execute permission we have 1. We can arrange these numbers to set the wanted permission using this way. As you can see in the table, if we don't want to give any permission we use 0, for execute only permission we use 1, for write only permission we use 2, for execute plus write permission we use 3, for read only permission we use 4, for read plus execute permission we use 5, for read plus write permission we use 6, and for read plus write plus execute permission we use 7. Now the first digit denotes the permission for the owner user and the second digit is for the group user and the third octal digit is for the other user. Let's take one more example. Give read permission to all users and execute permission to owner user only. Let's discuss about the second mode for chmod command, which is symbolic mode. In this mode, instead of using octal digits, we make use of characters. For owner user, we use a small u, for group user, we use a small g, and for other user, we use a small o. And for all users, we can use a small a. For adding some permission, we use the plus sign. For removing the permission, we use minus sign. And for assigning the permission, we use the equal sign. Please note, assign operator removes all the previous permissions. Let's have an example. Assign read, write, and execute permission to owner user and group user and read-only permission to the other user. Remove execute permission from the group user and remove read permission from the other user. Add execute permission to the group user and add read permission to the other user. Using comma operator, we can pass different types of permission in a single command for different users, as we have also seen in the examples. Also, if you want to set permission on a directory where all the files inside it will also be affected, then use -R flag. This flag represents recursive setting of the permission. If it is used, then all the files in the directory will be affected and will have the desirable permission set. Now we have enough knowledge about basic Linux file permissions. Let's discuss 3 special types of permission now. Please note these 3 special types of permissions can be very useful, but if handled poorly, they can create serious security loopholes by exploiting which an attacker may achieve complete control or higher privileges control over the operating system. SUID permission. SUID stands for Set UID Permission, also known as Set UID Bit Binary Permission. A binary file set with SUID permission is just a normal file but with extraordinary permissions. In simple words, an executable file with SUID is an special file not because of its content but because having SUID permission. So what's so special about SUID permission? Well, this permission allows a program or an executable file to be executed with the owner user privileges instead of being executed with the privileges of the user who launched it. In absolute mode, it is denoted with digit 4 in addition with the basic permission, and in symbolic mode, it is given with U+S. As you can see on the screen, every time we executed this SUID permission file, it launched with the owner privileges irrespective of the type of user who launched it. Now you can understand the danger of poorly handling the SUID permission. If you want to understand how SUID permissions can be abused, you can watch my other video where I have explained if SUID permission is handled poorly, then it can be abused to achieve complete control over the operating system. The link for it is in the description box and also in the I button at the upper right corner here. Anyways, let's move towards our next special permissions, which is SGID permission. SGID permission or Set GID permission is similar to SUID, but SGID set binary is executed with the group user privileges, unlike SUID, which is executed with the owner privileges. In absolute mode, it is denoted with digit 2, and in symbolic mode, it is given using G+S. The last type of permission we have is called sticky bit permission. Sticky bit permission is used to set on a directory. If this permission is set on a directory, then only the owner user can read, write, modify, or execute the files inside it, but no other user. For example, if a directory have a sticky bit permission set, then the owner of the file will have the full control over the file, which means full control of read, write, and execute, but no other user. The temp directory is the most common example of this permission, where the owner user have total control over the files they own, but not over the other files. In absolute mode, it is denoted with digit 1, and in symbolic mode, it is given by O+T. I have created a challenge or an exercise which contains some questions for you to practice. Feel free to share your answers or comments in the comment box below. That's all for today's video. I hope it has been informative for you. If yes, then please subscribe to this channel for more educational videos on cybersecurity and programming. And like this video, comment your thoughts, suggestions, or any query. We'll meet you again with another informative video. Till then, take care and goodbye.